Hello, welcome to a video on the beginning of section 3.7, which is on implicit differentiation. Now in class today, we started the first half of the first page of these notes, but didn't get quite to what implicit differentiation really is. But what I'll do is I'll recap the first half of the first page of these notes, then finish off the first page, and do most of the second page. So if we look at this equation right here, x squared plus y squared equals 9, hopefully you're able to recognize that that is a circle. And not just a circle, but a circle center of 0, 0, and raised to 3. So I'm going to create a few tick marks here. We know the center is at 0, 0, and that means that we'll have points in a circle that are 3 away from the center, like 3, 0, 0, 3, negative 3, 0, and of course 0, negative 3. That doesn't look that great of a circle. That's okay. Now, you're being asked this question: find the slope of the tangent to the circle at a point 2, negative 5. Well, that's not so bad. 2, negative 5 probably, we guess, would be somewhere over here. And of course, there's a tangent line. We want to find the slope of that tangent line to the circle at 2, negative root 5. Now, you haven't quite learned how to take the derivative of something like this: x squared plus y squared equals 9. We've done derivatives where y equals something in terms of x, where we find y prime or dy dx, dy over dx, and then we do product rule, quotient rule, or chain rule, or power rule, something to the side that contains x to get our derivative. Because remember, the derivative slope helps us find the slope of the tangent line, and then when we plug in the x coordinate for the point of tangency to get the actual slope of the tangent line. But what we could do instead is we can rewrite our equation x squared plus y squared equals 9 by isolating y. So we can subtract both sides by x squared, square root both sides, you get plus or minus 9 minus x squared, which is right here. And that's called an explicit formula because we're clearly told what y equals, where it's a bit more implied or implicit with x squared plus y squared equals 9 right over here. Now, if you tried graphing this in a calculator, we can actually separate it as two functions. We'd say y1 equals root 9 minus x squared, y2 equals negative root 9 minus x squared, where root 9 minus x squared would be the top half, and of course negative root 9 minus x squared would be the bottom half. Now, which one should we use if we're trying to find the slope of the tangent line to the circle at 2, negative root 5? If you said the second one, that's very good, because you want the bottom half, since our tangent line is going to be touching the circle in the bottom half. And we could probably rewrite it like this. Remember, square root is same thing as 1/2 as an exponent, so negative parentheses 9 minus x squared raised to 1/2 power is what y equals. Now if I take the derivative, we want to be really careful here. What we're going to do is we're going to do the chain rule by moving the 1/2 to the front. We have 9 minus x squared times the derivative of the inside. Derivative inside being negative 2x. So remember, derivative outside times derivative inside, that gets us the chain rule. Or that's how we do the chain rule. And of course I can see that the 2's cancel here, and there's got 2 negatives, right? So we could just say that the derivative is just oh, oops, that's a negative 1/2 power. I should be careful about that. Yeah, because we moved the 1/2 to the front, dropped the exponent by 1. Sorry about that. So anyway, we have x times 9 minus x squared to negative 1/2 power, or x over the square root of 9 minus x squared if you treat the negative exponent by putting on the bottom and then square rooting. Now in this portion right here, you're asked to find a derivative at x equals 2, which is going to get the slope of the tangent line at x equals 2. And that's easy. Just plug in 2 into your derivative, you get 2 root 5. So that's the slope of the tangent line. at x equals 2 for x squared plus y squared equals 9. And more specifically, x equals 2 comma negative root 5, because it could be 2 comma positive root 5 if we did the top half. Now, what if we did something called implicit differentiation? Now, let me show you how that works. So you have x squared plus y squared equals 9. What if we didn't want to isolate y? So instead, we take the derivative of both sides with respect to x. Well, the right side's easy. We have a constant there, so that's just 0. The other side, derivative of x squared is 2x. Remember, we're doing this with respect to x, so when I take the derivative of y squared, I will say 2y, but I must say dy over dx. You could kind of think of it this way. When I took the derivative of x squared, it's 2x times dx over dx, which of course those cancel. You could think of it that way, which is why we don't even write it in the first place. But when you take the derivative of a variable when it's taken with respect to a different variable, so we have y squared, but we change it with respect to x, you still do 2y, but you have to say dy over dx. That right there is going to be implicit differentiation. And we're going to want to isolate dy over dx, since that represents the derivative of y, with respect to x. So if I move things around, actually I'm going to erase that dx over dx since it's not really necessary there. So if I isolate dy over dx, this won't be too bad. 2y times dy over dx equals negative 2x. Divide both sides by 2y. dy over dx is going to be just negative x over y. Now, if I plug in 2 negative root 5, I have negative 2 up top, negative root 5 down below, you still get the same thing. So this could be a more efficient way for us to take the derivative of some functions where, or actually, I should take it back, this is not a function because this doesn't pass the vertical line test. So the derivative of a relationship or of an equation, where you have multiple variables and they're occurring in a lot of different places and a lot of stuff going on, like all these powers and stuff, like in the case of example 1. So it has to find dy over dx. So again, as an operation, I'm taking the derivative of both sides with respect to x. And the left side should be pretty standard, 3x squared plus 3y squared, but you gotta say dy over dx. 18xy. Now here you're going to have to use a product rule because x and y are being multiplied together. We didn't have to do anything like that on the left side because we just had x cubed plus y cubed. So I'll push the 18 out. It's going to be 18 x prime times y plus x times y prime. Sometimes we do that for shortcuts for derivatives. So 3x squared plus 3y squared times dy over dx equals 18 parentheses. Now it'll be 1 times y plus x. Now derivative of y is 1, but you got to say dy over dx. So whenever you're taking a derivative of a variable with respect to a different variable, you got to do something like that. Now we have to isolate the dy over dx's, so this is where the fun begins. So 3x squared plus 3y squared times dy over dx, just do with 18, 18y plus 18x times dy over dx. If you move things around, like you see here, minus 18x times dy over dx, and 18y minus 3x squared. Factor out dy over dx. You have 18y minus 3x squared all over 3y squared minus 18x. And that would be our derivative. And I kind of skipped a step right before. When we're over here, notice how I could factor out the dy over dx because 3y squared is being multiplied as well as 18x. or negative 18x. And of course, I divide both sides by 3y squared minus 18x. So now if I wanted to find, say, the slope of a tangent line for this equation at a particular point, I know what to plug it into. So here are the steps for implicit differentiation. You differentiate both sides of the equation with respect to x, collect all the terms of dy over dx or y prime on one side, and then factor out, then solve for dy over dx, like I did here. So this box is actually a great way to summarize what I just did. Let's try maybe a couple more here, and then I'll end the video, because your sub tomorrow, if you're D or E period, we'll go over this with you. And of course, if you're G period, I'll see you on Monday, since I'm not here tomorrow. So find dy over dx for this function, then find the slopes of 4, 3 and 4, negative 1. So I'm going to do the chain rule for the left side. So it's 2 parentheses y minus 1 to the 1 power times the derivative of y minus 1, because that's the inside, and that's just going to equal 1 on the right side when you take derivative of x. So you have 2y minus 1. Now derivative of y minus 1, derivative of y is 1, but you have to say dy over dx. And of course derivative of 1 is 0, and you still have 1 on the other side. So dy over dx is going to be 1 over 2 parentheses y minus 1. That's going to be our derivative. Now if you were to graph this function, x equals y minus 1 squared, not sure if you recognize this, but it's actually going to be a sideways parabola. For example, when y is 0, x is 1, and when y is 1, x is 0. I think I have this right. And let's see, also when x is 1, y could be 2. So you have sideways. Ugh, I missed. Kind of like that. So 4, 3, which I probably, okay, third time's a charm. Let's try this again. Probably should make that a little bit longer. So 4, 3 is right here. 4, negative 1, probably right there. So if you want to find slopes at those lines, well, that's easy. At 4, 3, there'll be 1 over 2 times 3 minus 1. Notice there's nothing to plug in for x, so that's just 1/4. And at 4, negative 1, there'll be 1 over 2, 3 minus negative 1, which would be, hold on, one sec here. Something seems a little fishy. 4, negative 1. So if I plug in 3, I got 1/4. Okay, that makes sense. And if I plug in, oh, geez, careless mistakes. Happens to all of us. Negative 1 for y. So in this case, you get negative 1/4. Yeah, and that's what helps a graph, because then I could confirm my answers. Of course, they weren't confirming each other, so I knew I made a mistake somewhere. Okay, so we'll go and stop there. I'll have your sub, if you're D or E period, to make sure you know, at least there's a recap for examples 1 and 2, and then you know, stuff before that, and then your sub will pick up from example 3, and hopefully you guys will get pretty far. Okay, well, have a great weekend, and I'll see you later.